Welcome to JSM Learn. Now we are going to solve previous year IIT JEE Main questions from sequence and series, and the subtopic is miscellaneous sequences. Let's see the first question. Here A1, A2, A3 are in AP and G1, G2, G3 are in increasing GP, and it is given that A1 is equals to G1 is equals to 1 and A2 plus G2 is equals to 1, A3 plus G3 is equals to 4. We are going to find the value of A10 plus G5 here. We know that general terms of AP are A comma, A plus D comma, A plus 2D. This is the first term, this is the second term, this is the third term. Here A is the first term and D is the common difference of AP. And we know that nth term of AP can be denoted by A suffix n, that is equals to A plus n minus 1 into D. And we know that general terms of GP, that is equals to G comma, G into R comma, G into R square. Here G is the first term, R is the common ratio. We know nth term of GP is equals to G into R to the power n minus 1, which is denoted by G suffix n here. So from the given data, we know that A1 is equals to A is equals to 1 and G1 is equals to G is equals to 1. And then next it is given that A2 plus G2 is equals to 1. We know that A2 is equals to A plus D and G2 is equals to G into R. So from this we can write this A plus D plus G into R is equals to 1 from the given data in question. By substituting A is equals to 1 and G is equals to 1, we will get 1 plus D plus R is equals to 1. On simplifying this, we will get D is equals to minus R. So next it is given that A3 plus G3 is equals to 4. We know third term of AP is equals to A plus 2D and G3, that is equals to third term of GP, that is equals to G into R square. From the given A3 plus G3 is equals to 4, we can substitute this A plus 2D plus G into R square. So by substituting A is equals to 1 and G is equals to 1 and D is equals to minus R, we will get 1 minus 2R plus R square is equals to 4. On rewriting this, we will get a quadratic equation R square minus 2R minus 3 is equals to 0. So on simplifying this or finding the roots of this quadratic equation, we will get R is equals to 3 and R is equals to minus 1. Here it is given that it is an increasing GP. So R must be greater than 1, right? So we cannot take R is equals to minus 1. Here R is equals to 3. So we got R is equals to 3 and D is equals to minus R, right? So from here we got D value also minus 3. Now we are going to find A10 plus G5 value. So we got A1, A value is equals to 1 and G value is equals to 1, R is equals to 3 and D is equals to minus 3. Now we are going to find A10 plus G5 value, right? We know A10 is equals to 10th term of AP, that is equals to A plus 9D and G5 is equals to 5th term of GP, that is equals to G into R to the power 4, right? So by substituting these two over here, we can write this as A plus 9D plus G into R to the power 4. By substituting all these values, we can get 1 plus 9 times minus 3 plus 1 into 3 power 4. So on simplifying this, we will get 1 minus 27 plus 81, that is equals to 55. So sum of 10th term of AP plus 5th term of GP is equals to 55. So we got option D as our answer. Let's see the next question. Here a sequence is given and we are going to find the sum of 8 terms for this sequence. By observing this sequence, we got to know that in numerator it is sum of cubes of first n natural numbers, and in denominator we are having sum of first n odd natural numbers. We know that sum of first n natural numbers cubes is equals to n into n plus 1 by 2 whole square, and sum of first n odd natural numbers, that is equals to n square. By seeing these two formulas, we will substitute it in nth term of this sequence. So here sum of cubes of n natural numbers is equals to n into n plus 1 by 2 whole square. Then sum of first n odd natural numbers is equals to n square, right? So on simplifying this, we get n plus 1 by 2 whole square, that is equals to n plus 1 whole square by 4. So on expanding this, we will get n square plus 2n plus 1 by 4 as nth term of this sequence. We are going to find first sum of 8 terms. So this I will indicate with S8, that is equals to sum of 8 terms, which can be written as sigma n is running from 1 to 8 Tn, which means T1 plus T2 plus T3 plus up to so on so T8 we are going to add. Sigma n is running from 1 to 8. Nth term of this sequence is n square plus 2n plus 1 by 4, right? That I am writing here. N square plus 2n plus 1 by 4. Here this denominator 4 can be taken outside the summation term. So 1 by 4 times sigma n is running from 1 to 8 n square plus 2n plus 1. So this is the sum of 8 terms value. Now we are going to simplify by multiplying the summation to each term of this Tn. So sum of 8 terms is equals to 1 by 4 times sigma n square, where n is running from 1 to 8, plus sigma 2n, where n is running from 1 to 8, plus sigma 1 n is running from 1 to 8. We know that sum of squares of n natural numbers, that is equals to n into n plus 1 into 2n plus 1 by 6, and sigma 2n, right? So we can take this 2 outside to the summation term and we will get sigma n, right? Sigma n means sum of first n natural numbers, that is equals to n into n plus 1 by 2. Here sigma 1, that is nothing but adding 1 for 8 times, that is equals to we will get 8 over here. So 1 by 4 times we will write the first formula. Sigma n square means n into n plus 1 into 2n plus 1 by 6 plus 2 times sigma n, right? So that is nothing but n into n plus 1 by 2 plus sigma 1 n is running from 1 to 8, that is equals to n. So here n is equals to what? 8, right? So by substituting n value 8 over here, we will get 8 into 9 into 17 by 6 plus 8 into 9 plus 8. So on cancelling 6 with the 9 and 8, we will get 12 times 17 plus this will be 8 into 10 times, right? So on cancelling it with 4, we will get 3 times 17 plus 2 times 10, that is equals to 51 plus 20, that is equals to 71. So we got sum of 8 terms of this sequence is equals to 71. 1. So we got option B as our answer. Let's see the next question. Here sigma n is running from 1 to 10, 528 by n into n plus 1 into n plus 2 value we are going to find. Now I am considering this sum and rewriting this term as 528 times sigma n is running from 1 to 10, 1 by n into n plus 1 into n plus 2, and I am considering this as sum of 10 terms, that is denoted by s suffix 10. So we got this s suffix 10 is equals to sigma running from 1 to 10, 1 by n into n plus 1 into n by 2. So from here I am writing this 1 by n into n plus 1 into n plus 2 as nth term of this particular sequence. Now I am going to multiply and divide with 2 on this nth term. Now Tn, here I am multiplying and dividing with 2, right? So I am writing numerator inside and 1 by 2 as outside. So here n into n plus 1 into n plus 2 is the denominator, right? So here now I am adding plus n and minus n. Now I am splitting the denominator for these two numerators, that is equals to 1 by 2 times n plus 2 by n into n plus 1 into n plus 2 minus n by n into n plus 1 into n plus 2. So here I am converting this sequence into a telescopic series. Here this third term and third term will get cancelled. Here first term and this first term in this denominator will get cancelled. Finally this will convert into 1 by 2 times 1 by n into n plus 1 minus 1 by n plus 1 into n plus 2. So this is our final nth term of this given sequence. Now we are going to find the sum of 10 terms, right? Here n is running from 1 to 10. That means T1 plus T2 plus T3 plus up to so and so T10. That is nothing but sum of 10 terms, that is equals to T1 plus T2 plus T3 plus up to so and so T10. We know Tn, that is nothing but nth term of this sequence is equals to 1 by 2 times this 1 by n into n plus 1 minus 1 by n plus 1 into n plus 2. By substituting n is equals to 1, n is equals to 2, n is equals to 3 up to so and so n is equals to 10, we can find the 10 terms and we can add, so that find sum of 10 terms. So nth term of this sequence is equals to 1 by 2 times 1 by n into n plus 1 minus 1 by n plus 1 into n plus 2. So here we are going to substitute n is equals to 1, right? That is equals to first term 1 by 2 times 1 by 1 into 2 minus 1 by 2 into 3. Next n is equals to 2, we will get a second term, that is equals to 1 by 2 times 1 by 2 into 3 minus 1 by 3 into 4. Next n is equals to 3. So here we will get third term of this sequence, that is equals to 1 by 2 times 3 into 4 minus 1 by 4 into 5. Up to so and so we need to find n is equals to 10, that is equals to T10, that is equals to 10th term, right? So 1 by 2 times 1 by 10 into 11 minus 1 by 11 into 12. So by observing these terms, if we add all these terms, here 1 by 2 times minus 2 by 3 and 1 by 2 times 2 by 3 will get cancelled. Next 1 by 2 times minus 3 by 4 and 1 by 2 times 3 by 4 will get cancelled, and it will continue further also. So up to last term it will get cancelled, and the remaining two terms are, here it is equals to sum of 10 terms, right? That is nothing but T1 plus T2 plus T3 plus up to so and so T10. So here finally the remaining two terms are 1 by 2 times 1 into 2 and here 1 by 2 times 1 by 11 into 12. So I am taking 1 by 2 common. So the first term, that is 1 into 2 minus the last term is 1 by 11 into 12 here. So on simplifying this, we will get 1 by 2 times 1 by 2 minus 1 by 132. So by doing LCM for this, we will get 66 minus 1 by 2 times 132, that is equals to 65 by 264. But actually we are going to find the value of 528 times sum of 10 terms. So from here we can write 528 into sum of 10 terms value we got 65 by 264, right? So that is equals to 2 times 65, that is equals to 130 is our final answer. Here option B is 130. Thank you for watching.